This conference will now be recorded.
This is a pretty dynamic situation that's ongoing in California, and I think we're seeing the cascading effects of drought right now. First, in terms of wildfire, and then perhaps in terms of effects on the landscape. So, we'll get into that, and that'll be part of the conversation here. So, this is the Southern California sector specific drought outlook. We have a few introductory slides just to get some folks up to speed who may not have been part of these conversations before. Our vision right here is to provide and have drought resilience for the nation's economic sectors. Our mission here is to inform early warning decision making, and the process is to deliver monthly sector specific drought scenarios based on integrated and tailored monitoring and forecasting information that you will see in the following. We're focusing on three sectors here: agriculture, water utilities, and public health. We're doing this in the context of the greater Southwest United States because the hydroclimate of the Southwest is intimately tied in with Southern California. So you'll see both of these perspectives presented as we move through the presentation. In terms of when we're providing these briefings, we've provided two thus far, one in October, one in December, and this is our first of 2025. Because of the holidays and several activities that were going on, this is our first of the year, and we haven't met for quite some time. So we have had considerable deepening of drought in California, and also a situation that has evolved in quite a severe way. We'll provide several more drought early warning statements and presentations over the several months, one a month from now at the end of February, again at the end of April, and at the end of March and the end of April. So there's some typos in there. So in terms of sector-specific perspectives, we're constantly looking for feedback from folks who are using this information. And what kind of questions do you have about drought? It could be about how drought is forecast to evolve, or more generally, questions about drought that may provide insights and allow you to understand a little bit more about what we're talking about. What are you considering? What topics are you considering related to drought and its cascading effects? And this is an area right now where we are seeing cascading effects of drought, obviously fires, and then perhaps effects on the landscape as a result of fires, whether it be mudslides or whatnot. So these are considerations here that we would love to hear your feedback on, whether they're here within this presentation, but outside and through email. As Amanda said before, we are taking three different perspectives here in order to provide this sector-specific drought briefing. The first is a global perspective. What conditions across the globe are relevant to Southern California sectors? And there's several of which that are pretty long-lived in terms of their behavior that provide some aspect of predictability over Southern California. The second is the regional perspective. Southwest US conditions that are relevant to Southern California sectors. That is of obvious importance because, like I said before, the Southwest US and Southern California are tied in pretty closely in terms of hydroclimate. And then finally, providing the sector-specific drought outlook for water utilities, agriculture, and public health. So in terms of the lines of evidence, we're using observed conditions, the latest that we have as of this morning. We're using predictions, and we have expert interpretation of many types of forecasts to anticipate the future, and also using other tools that combine season-to-date observations with historically similar periods to project chances of outcomes in the future. Now, when it comes to interpreting these sector-specific scenarios, we've adopted a level of confidence: high confidence, medium confidence, and low confidence. When we started this exercise in October, most of our sector-specific scenarios were at a medium confidence level, given the variations in climate that we can see over the Southwest and Southern California. Those scenarios are now high confidence. Unfortunately, the forecasts that we were making at that time in October have come to fruition. And as a result of that, there's really close agreement among our several robust sources of evidence. So what I'll do here is I will present each of the different perspectives, the global, the regional, each of the sectors, and then I'll open it up to questions from folks who may be in the audience. And I'd invite folks to write questions in the chat as well. I do have some limited capability to get in there and sort of read them off in real time. So it would be great to see those questions if you have any. So moving on here to the global perspective, we look at the El Nino Southern Oscillation, and it is composed of three phases: El Nino, La Nina, and neutral. And they are used to predict outcomes in the future because of known behaviors and relationships between those three phases and Southern California weather and climate. The second point here is that a weak La Nina is expected to persist into early spring 2025, and that increases the chances for below average precipitation in Southern California. This is a fairly idealized plot, but I think it gets the point across where it shows that when we have a La Nina event, we have wintertime conditions in Southern California that tend to be dry. And that is unfortunately what has happened so far in Southern California's wet season and is forecast to persist. So this right here is a really important source of predictability for what we're looking at here in terms of drought evolution. There are several different ways to be able to measure the El Nino Southern Oscillation. One is by an index of sea surface temperatures in the tropical Pacific Ocean, this being the Nino 3.4 index. It's used in several different applications. And really what you're seeing here in the most recent trace is for these below normal sea surface temperature anomalies. And that right there is indicative of an ongoing La Nina event. That was declared by our colleagues at the NOAA Climate Prediction Center earlier this month. Now, in terms of the La Nina forecast, it's forecast to persist into early spring of 2025. And you can see this here with these 3-month seasons that are used to forecast the ENSO state as we go forward. So DJF, that's December, January, February. That's the season that we're currently in right now. And then JFM, which is January, February, March, and so on and so forth. So you can see that La Nina is the most likely state of the El Nino Southern Oscillation all the way into the February, March, and April season. So persisting through the Southern California wet season, as indicated by our colleagues at the NOAA Climate Prediction Center. Another important climate mode that we look at is called the Madden-Julian Oscillation. So the Madden-Julian Oscillation, it's composed of 8 phases, and those phases, they indicate the movement of the Madden-Julian Oscillation across the Indian and Western Pacific Oceans. So the Madden-Julian Oscillation has been in a phases 2 and 3, and it has been fairly strong. And this is increasing the chances of a precipitation event in Southern California this weekend. And we'll talk a lot more about that in the coming slides. Here's another idealized schematic. This one is from climate.gov. And what it indicates is the behavior of the Madden-Julian Oscillation when it's in the phase that it's in currently right now, and how that affects California in terms of atmospheric river activity. So essentially, when we have a Madden-Julian Oscillation that looks like so, when we have enhanced precipitation in the Eastern Indian Ocean, decreased precipitation in the Western Pacific Ocean, that enhances the storm track and then allows for moisture-bearing storms to move into the west coast of the United States and Southern California. And that's the situation that we're in right here. So let me pause right now, and if there are any questions, we invite folks to ask them. Okay, well, hearing no questions, we'll move on to our regional perspective. So when we move on to our regional perspective, we contextualize current drought, and then we'll move on to drought forecasts. So in terms of drought context, this is the current drought. Drought continues to intensify across Southern California and the Southwest United States. And the second here is during October 1st to January 12th, Southern California precipitation was the second lowest and temperatures were the second highest for such a period since 1951. And then finally, snow water equivalent is generally average and below average across the Southwest, which is consistent with below average precipitation across the Southwest. These series of maps right here show the U.S. Drought Monitor. So the U.S. Drought Monitor considers several different types of drought and its impacts. It's an aggregate product whereby it takes into account all the different facets of drought that we look at to be able to produce this aggregate composite of what we think drought is how drought is behaving right now. There are different facets of drought that are important to each individual sector, and we'll outline that here. But the U.S. Drought Monitor is really a first-order place to start in terms of how drought is behaving. So the U.S. Drought Monitor indicates drought in 4 different phases: D1, D2, D3, D4, and an abnormally dry phase here, which is shown in yellow. And as you can see, as of January 21st, so just a few days ago, and this map was released this morning, it indicates that across the Southwest United States, we're seeing considerable drought extent across that region, especially in our Southern California region, impinging into the areas in which we have seen fires most recently. Now, in terms of drought monitor class changes, this is to indicate how drought has emerged since October 29th. So this is just showing the differences in drought classes between the 21st of January and October 29th, and indicating here that we've had a pretty notable onset of drought in our Southern California region here. And you can see that by the deep brown colors that have been drawn in Southern California. Now, the emergence of drought, especially over our Southern California region, is related to low precipitation that we've seen since October 1st. This is from a data set called Incline Grid. This is produced by NOAA, National Centers for Environmental Information. It's pretty high resolution, so you can see that it's fairly smooth, but at the same time, it does have some data outages, and the most recent data outage has limited our data extent to January 12th. So these maps are about 11 days old right now. So we haven't seen we haven't seen any precipitation since the data outage occurred. So these deficits have only intensified, but they are a little bit dated. So please note that. On the left is precipitation percent of average. So you can see the percent of average precipitation compared to a 1991 to 2020 baseline. And it indicates that in Southern California, we've seen less than 5% of the average precipitation for such a period, that being October 1st to January 12th. On the right here is precipitation percentile rank. So this here to give an indication of how this year stacks up against all prior years since 1951. And as you can see here, this percentile rank precipitation indicates that it is in the lower 5th percentile. It's actually number two in rank across a wide swath of the Southwest United States and Southern California. In terms of temperatures here, near record high temperatures in Southern California since October 1. So this has been a compound extreme, as we call it, low precipitation, high temperatures across the Southwest, obviously exacerbating drought. On the left is the temperature departure from average compared to 1991 to 2020, and you can see that temperatures across the Southwest are about a degree Celsius warmer than they were for the average of 1991 to 2020. On the right is the temperature percentile rank, and that right there indicates that since 1951 to 2024, we are in the upper 5 percentile, and actually across most of the Southwest, this is actually ranking as the second warmest since 1951. Now, when we put these together, what we can do is we can take our Southern California region, which is indicated by these 9 counties in the Southwest. We can average precipitation and temperature across them for the 1st of October to the 12th of January, and see that 2024 to 2025 is the second driest and also the second warmest. It's really an outlier here. You can see comparable seasons here, like 1999 to 2000, October 1st to January 12th, where that was rivaling in terms of precipitation, but not so much in terms of temperature, a half a degree Celsius lower than that 2024-25 period that we've been in. 2017 to 2018 was another time where we saw exceptional temperatures, and cumulative precipitation during that time is a little bit higher than what we see right now. So the 2024-2025 period, very exceptional in terms of its compound extremes. Now, noting that we've seen below average precipitation and above average temperatures over the Southwest United States, consistent with that, we see low snow water equivalent across the Southwest United States as well. Some areas are as high as, say, 90% of average to 110% of average that's indicated by the green. But by and large, whether it's in California or even back into Utah or in the Colorado River Basin, we're only indicating average and perhaps below average conditions here. We still have a long way to go in terms of the snow accumulation season. And that right there is a cause for being optimistic. But on the other hand, we're not so optimistic, as we'll show with the forecast, that below average precipitation is in the offerings and is most likely across that region of the globe. Now, getting into forecasts that are relevant to drought, the first part here is that the first precipitation event of the 2024-2025 wet season in Southern California is really upon us. And That's forecast to occur this weekend and really couldn't happen soon enough. The second point here is being a little bit more forward-looking is that drought is expected to persist in the southwest U.S. through the end of April 2025, according to the NOAA Climate Prediction Center. And likewise, forecasts indicate increased chances of below average precipitation and above average temperatures through April 2025 in the southwest. Now, before we get to this weekend's precipitation event, we do need to call out that for today and for tomorrow, there's elevated and critical fire weather outlook. This is produced by the Storm Prediction Center. Now, again, in the midst of drought, there's a very dry land surface. We got Santa Ana winds. We have that situation setting up right here that is not good for fire. And this being one of the downstream effects of the drought that we're in is that the land surface is just more prone to burning just because of the way the weather and the climate have behaved so far this season. Now, the first precipitation event of the 24-25 season is upon us and is forecast to occur this weekend. And that should really help to alleviate some situations as it relates to fire. Now, what is being shown here is the precipitation forecast from when these models were run. On the left is the ECMWF model. On the right is an aggregate product put together by the Weather Prediction Center. And what they indicate is precipitation forecasts for 168 hours in the future. And this is through the 30th of January at 12 UTC. So basically pretty late at night on the 29th of January. And as you can see, precipitation across much of the southwest United States is anticipated, though there is a little bit of differences in how each of the models that are being used here, they are indicating how much precipitation is going to fall. This is a product that the images are from CW3E, and we're very grateful for their partnership. Now, just to put a little bit more emphasis into this precipitation event, unfortunately, if it rains too hard, that could really produce landslides, because when you get into those situations where there's considerable fire, there's not much vegetation anymore to really hold that soil into place. So if you get too heavy precipitation, you get mudslides. What it's looking like right here for Southern California is that their light precipitation is forecast to fall this weekend in two periods, one on Saturday and one late on Saturday. So this is for a given point that's indicated right here, Southern California. This is indicated in yellow. And what we can see here is light on the light side of precipitation for this point spread apart into two periods. So this is not heavy, thankfully, but we do need to continually monitor this. And our Weather Service colleagues, I'm sure, are really on top of this right now because of this emerging situation. Now, just getting into a more longer lead forecast. So this is the NOAA Drought Outlook. This is produced by the Climate Prediction Center. And these brown colors here indicate the persistence of drought from now all the way up through the forecast period, which is April 30th of 2025. These yellow colors indicate the forecast drought development across the Southwest. So because of below average precipitation that I'll show in the following slides. Further drought deepening, further drought development in space across the Southwest, and obviously that includes Southern California. Now, in terms of week 3 and week 4 outlooks, outlook for precipitation is on the left, outlook for temperatures is on the right. This is produced by the NOAA Climate Prediction Center. These are forecasts that were made on January 17th. They're made once a week, and these forecasts are valid for the 1st to the 14th of February. And what you can see here is that there's equal chances of precipitation being above or below average in Southern California. That right there doesn't really speak to any sort of confidence of any drought alleviation right there. There's just not much of a signal to be able to draw from in terms of the forecast. Though over the rest of the Southwest, below average precipitation is preferred. Same goes for temperatures as well. Now, unfortunately for the seasonal precipitation and temperature outlooks, they are not optimistic over Southern California and the Southwest. So these are forecasts for February, March, and April of 2025, and these forecasts were issued last week, January 16th. And as you can see over the Southwest, below average precipitation is the most likely outcome there, as is above average temperatures. As you can see here, the above average temperature forecasts and the likelihoods of them are a little bit outside of our Southern California region. And that right there should be noted as well. Now, before we get into the sector-specific outlooks, are there any comments or questions on the current state of drought, the forecast state of drought, and anything in between? Okay. Well, hearing none, let's go into each of the sectors, and we'll begin with water utilities here. So the water utilities scenario that we've created and we've maintained for some time, and we say this with high confidence, is reservoir storage and groundwater levels are expected to be lower in October 2025 compared to January 2024. The supporting evidence here is as follows. We have increased chances of below average precipitation and above average temperatures in the 2024-2025 wet season and below average snow water equivalent in spring 2025 as a result of that. Also, low groundwater levels, they're due to the chances of recharge, them being low through October 2025 due to forecast below average precipitation in the ongoing wet season amid continued use. And that several areas in Southern California are reporting low groundwater. Now, as I said before, in terms of each of the individual sectors, there are certain indicators that are of principal importance. And obviously, for water supplies or water utilities, water supply is very important. That being from reservoirs, that's shown on the left, and on the right, groundwater. So this is as of January 22nd, produced by California Water Watch, and just indicating what the percent of average is on the left for reservoir storage, and on the right, groundwater level percentiles. As you can see on the left, reservoir storage is in a good place, generally average and above average. The reason being is we're coming off of 2 years of above average precipitation that really helped to replenish those water supplies right there. And even though we have been in drought for several months now, and we've seen the emergence of drought in some facets, we're not seeing it here in water supply. And that just goes back to how different facets of drought can behave differently. On the right is groundwater, and groundwater is pretty mixed. You see some areas where there's low groundwater, and that's a result of continued use, but there are other areas as well, especially in Southern California, that are near the median value and perhaps even above the median. Now, in terms of looking ahead, what we showed before is that below average precipitation is the most likely outcome for several months into the future. So what we've done here is to take observed conditions through the 12th of January, for which we actually have data, and to be able to take into account some scenarios of the future. The first here is all historical. So what we do is we take precipitation as observed through the 12th, and we take all historical outcomes, and we put it together, and then we calculate the probability of being below average, that being the 33rd percentile, and above average, the 66th percentile. We do the same on the right, but instead of using all historical outcomes, we only use a subset of those outcomes. And that subset of outcomes includes no El Nino years. And we use the post-2000 no El Nino years in order to best represent the situation that we're in right now. That being, we have a weak La Nina event, and also we're in a warmer climate than we were before. So we try to use a more contemporary climate. Both paint a pretty stark picture in that below average precipitation is the most likely outcome, given that inclusion of observed conditions plus some historical conditions. The no El Nino case is really quite stark. La Nina years and neutral years tend to be below average in terms of precipitation. And then when you combine that with below average precipitation to the magnitude that we've seen right now, that really yields a very high likelihood of below average precipitation. We perform the same analysis, but do so for temperatures here. Unfortunately, when we do this analysis just based on the situation that we have seen and observed over the last number of months, that so considerably tilts the odds to above average temperatures. And we're seeing that right here, that above average temperatures are almost near certain for the October 2024 to May 2025 period. Another important facet to include in here as well is snow water equivalent. So these are maps produced by NRCS, and what they're showing is several historical La Nina years and the snow water equivalent on April 1st of that year. We use April 1st because it's nominally the time of year where we have the peak snow water equivalent on the ground, and therefore use that in a way to be able to measure what kind of water resources we'll see in the future. Unfortunately, for most La Nina years, we tend to see below average snow water equivalent in the Southwest. That exception was actually 2023. 2023, we did not see below average snow water equivalent. You can see all those blue colors right there. That just goes to show that not all La Nina events produce low snow water equivalent, but most do, and that's highlighted there in the three other images. So with that, I'll just linger over this for a moment and ask if there are any comments, questions, suggestions, or clarifications that folks may have. All right, well, hearing none, we'll move on here to our agriculture sector. And the scenario that we're providing here is that crop stress, which may reduce agricultural productivity, is expected through spring of 2025 in Southern California. And we have three lines of supporting evidence. The first is current low soil moisture in Southern California, and that is forecast to persist. The second is below average precipitation in Southern California is most likely due to decreases in the number of days with no precipitation. And then finally, above average seasonal temperatures are most likely in Southern California. So these are soil moisture percentiles shown over the entire United States as of the 18th of January 2024. So this is produced by a land surface model, and the image is courtesy of NOAA Climate Prediction Center. So what this land surface model is exposed to is historical conditions of precipitation, temperature, and any relevant forcing that's necessary to be able to produce soil moisture. And what it does is it paints a picture of what soil moisture percentiles look like as of that date. As you can see in Southern California and the Southwest United States, there's very low soil moisture percentiles across that region, which actually looks pretty similar to what you see out of the observed precipitation to date in the current wet season. And as a result of that, that right there is really highlighting an agricultural drought as it's going on, especially in rangelands, which may not be irrigated. Now, this is a soil moisture forecast. What this forecast does is it takes into account current land surface conditions as of the 10th of January, and then it incorporates in a land surface model forecast conditions for the next several months. So this is a valid forecast for January to June of 2025. And as you can see in the Southwest United States and Southern California, that it's most likely to see low soil moisture percentiles by June of 2025. So that is a result of the observed soil moisture date and also the precipitation, temperature, and other important factors that are included within this land surface model. So low soil moisture by the end of June of 2025, consistent with our drought outlooks for the next several months. This right here is precipitation. And with this precipitation right here, what we're indicating is increased chances of below average precipitation. And we've noted this in prior slides. This is an image that I showed previously. What I didn't show previously is the chances of wet days. So what we've done here is to use observed conditions through the 12th of January in terms of wet days, and then include all historical conditions in the historical record that we have. On the right, we do the same, but we only include no El Nino years and see what the outcomes are for increased or decreased chances of wet days. So in this case, when we're in the lower 33rd percentile, it means we have a decreased chance of wet days. And if we're in the upper 66th percentile, it means we have an increased chance of wet days. Now, consistent with below average precipitation that for the season that is indicated by this perspective, we also have a decrease in the number of wet days too. And that's pretty noteworthy here in the case of no El Nino, which is the type of ENSO state that we're in right now. I showed this previously, so I won't linger on it too much, but what it indicates is that above average temperatures are near certain in the Southwest United States, and just an unfortunate reality of the situation that we're in. I showed this last month, and what it shows is the chances of days below freezing. And this is a little bit of a different perspective. We used a different data set last month, which actually provided some fairly different results. It really gets down to different data sets are constructed in different ways and provide different perspectives. So what you're noting here is that when we are in the lower 33rd percentile, these reds, it indicates that we have a decreases in the chance of freezing days. And if we're in the blues, it means we have an increase in the chance of freezing days. Now, last month, when we showed this perspective, we actually had an increase in the likelihood of freezing days across much of the Southwest and Southern California. That is not quite the case here within this data set. It could be because of the data set that we're using. It also could be because, and we can't rule this out, it could be because we've gotten past the time of year where this is actually relevant, that is freezing days. So it's probably a little bit of both. So last month, what we were indicating is an increased chance of freezing days, and it doesn't appear that that is the case any longer based on the evidence that we have. So this is the agriculture scenario, and I'll let it linger here and ask the audience if there's any comments or questions. I see a hand up. It's Annie. Annie, go ahead.
I also put this in the chat, but I was curious what data set you used last month and what you're using this month, and if you could talk a little bit more about the differences between the two data sets, like how they're constructed and why they're providing different.
Yeah, that's a great question. So the data set we were using last month had a horizontal resolution of a quarter degree by a quarter degree. So nominally 25 kilometers in the zonal direction and the meridional direction, for lack of a better term. This time we're using a data set here that has a 4-kilometer resolution. So it separates the globe into boxes that are 4 kilometers by 4 kilometers. The latter data set, the one that you're seeing here on this slide, or I'll go back to that slide right here. This data set is produced by NOAA. It's NCEI's Incline Grid. The other data set is also produced by NOAA, and it's produced by the NOAA Climate Prediction Center. They serve some different purposes, honestly, and they were produced sort of at different times. Like the Climate Prediction Center data set is several decades old, whereas the Incline Grid data set is within a decade old. And they serve different purposes. But the Incline Grid data set probably has a more robust data set that goes into this, and as a result is able to resolve topography a little bit more than the other data set, horizontal resolution notwithstanding. So there are differences within the data sets here, and they will produce somewhat of different answers. Does that answer your question, Annie?
Yeah,
Okay, Jesse has a hand up. Jesse, do you have a question? I see you've unmuted your mic, but I can't hear you. Okay, would you mind typing your question? Is that okay? Okay, so if you still have a question, why don't you, oh, there it is. Okay, not to be a downer, but we've seen changes in HHS having canceled meetings and a freeze on updates from their end. Do you anticipate administrative changes impacting NOAA at this time? I would say it's a pretty dynamic situation, but I can't really speak to any changes impacting NOAA. I'm not aware of any, and probably not in a position to actually say so. So sorry to not have any information, but yeah, I think it's above my pay grade. Thank you. Right. All right. So let's move on here to public health. And again, if there are any questions about what we just covered before, please feel free to put them in the chat, and we'll come back and revisit them. So here's the public health scenario. And unfortunately, it seems as though this has come come to fruition already because of the Southern California fires. So poor air quality is expected during the winter and spring 2025 in Southern California due to wildfire smoke and blowing dust. So in winter and spring 2025, air quality will likely be reduced by smoke from wildfires burning in Southern California. And then in spring 2025, air quality will likely be reduced by airborne particulates due to above average wind speeds blowing over a dry land surface caused by below average precipitation during the 24-25 wet season. So we'll begin here with the air quality index and wildfires on the 23rd of January. So this was this month when I was able to put together, and I was able to grab this image here. What it indicates is low air quality in areas that are concurrent with fires here in Southern California. This is obviously an evolving situation here, and it seems like some more fires are now burning in that region. So this map actually, just because of the emerging and dynamic situation, is probably outdated, even though it was only taken earlier this morning. Now, the fire season that we have endured and the ongoing fires that we are experiencing right now is really because we have not seen any meaningful precipitation since the 1st of October. And this has prolonged the fire season that tends to come to a close sometime at the end of a calendar year. And this right here, I'm not going to go over the image any further, but it does indicate that we've seen exceptionally low precipitation in the Southwest United States. I've already shown this image as well. And what it indicates here is that we have greatly increased chances of below average precipitation during October 2024 to May 2025, based on conditions to date as of the 12th of January and historical conditions selected from the entire history and no El Nino year since 2000. Now, one perspective that we were sort of asked to undertake, and this is a reasonable one, is to be able to understand and forecast the chances of above normal winds in Southern California. So this right here is from Copernicus Climate Change Service. So what they do is they don't do climate change. They just put together a bunch of seasonal forecasts. And this is for the February, March, and April season. And these were forecasts made of January. And what they show are the chances of above and below normal wind speeds. So with the warm colors, yellows and oranges and reds, those indicate the increased chances of above normal wind speeds. And likewise, the cool colors indicate the opposite. But as we can see over Southern California, we are under a forecast of above average wind speeds. And that really is not good news, just because the land surface we expect to be quite dry. And as a result of increases in wind speed, we would expect there to be more blowing dust than there otherwise would be because of the combined effect of these two factors here. We also noted in previous months that the winds tend to be from the west and northwest in Southern California during that time of year, February, March, and April, with a pretty overwhelming frequency. So we could expect areas that are sort of in the eastern side of dust sources to be really impacted by poor air quality as we move into the spring and into the summertime seasons. So that right there is the public health scenario, and I'd be happy to address any comments or questions that folks might have. Oh, Annie, your hand is up. Go ahead.
So is the wind prediction, are those a different set of winds than like Santa Ana winds? I thought Santa Ana winds were from the east side going towards the coast. Or did I get that wrong?
Could you repeat that? You cut out a little bit. I think it may have been a problem on my end.
Okay, so the wind forecast that you just showed, you're saying the direction of the wind is from the west and going east?
So that forecast right there does not indicate wind direction. It only indicates the speed of the wind. And what we know from some of the analyses that we had presented in past months is that Southern California experiences mostly west and northwesterly winds that time of year during its wind episodes. So that we would expect to have west and northwesterly winds during that time. But unfortunately, that image right there only indicates the increased likelihood of above average winds.
Okay, so that means it's blowing from the west, or it's blowing to the west?
Blowing from the west, so west to east. So when we say it's a westerly wind, it means it's blowing from the west to the east.
Okay, so I guess is that time period after when we would expect the Santa Ana wind activity? Because I guess right now it seems like the wind would be going east to west.
Right. So this is after the Santa Ana winds activity, number one. And also number two, the perspective that we were taking before was a little bit more of a regional scale as opposed to that local scale that we're seeing right now.
Okay, that helps explain. Thank you.
Well, thank you. Thank you for that clarifying question. Question about the utilities analysis. You noted that reservoirs were forecast to be lower than average because SoCal conditions between October 2024 and January or May 2025. Does that account for the source water of the different reservoirs in the region, or base it on the precipitation within the region? So it bases it on the precipitation within the region. And I saw Mike Anderson on the call here, and Mike works with us very closely and has helped to conceive this effort. And Mike, if you have any perspectives on source water from different reservoirs, please feel free to chime in.
Yeah, hi everybody. Mike Anderson, state climatologist with the California Department of Water Resources. So the analyses presented here really look at local supply. The reservoirs in the region can have different sources from either Colorado River, Owens Valley, or State Water Project. We do know that the Colorado River water has a full allocation for California for this year. State Water Project, they will have a updated allocation number here in the beginning of February after the snow survey and bulletin 120, which is the water supply forecast, are done. Do not have information about supply from Owens Valley, as that is owned and operated by Los Angeles Water and Power. So that does need to be factored in to the information presented here. That helps.
Is it going to be? Hi, Mike. This is Julie Ekstrom.
Hi, Julie. No, because it is an extraordinarily complicated process between water that's able to be moved for direct use supply versus water moved for storage for future years. So much of that is due to so many factors beyond climate that it really wouldn't be included here. What we're trying to convey here is that the parts of the region's portfolio that depend on local supply will be missing that key piece to a large degree. And so consequentially, there is a greater reliance on the imported component.
Go ahead. I think can I get it? Okay, thank you.
Thank you, Julie, for the question. And yeah, thanks, Mike, for the answer. Now, are there any other comments, questions, feedback from the audience? It doesn't have to necessarily be related to the public health scenario. It can be related to anything.
You want to go ahead and wrap up, Andy? I can.
Yeah, we thank you all for joining. And obviously, in the meantime, before we provide our next outlook, if you have any comments, questions, feedback, or you'd like us to emphasize anything, please let us know.
And per usual, we'll be sending out the recording and the write-up tomorrow. And I'm looking at the next date for this is February 27th. We keep that on the books. All right. Thank you, everyone.
Thank you, Amanda. Thank you, Andy.
Thank you.
Yep.